Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number, I think it's 6 part B from the Pure Mathematics 2 paper from Cambridge 9709, February-March 2020. This question, part B of this question, is about numerical methods and iteration, and I'm going to save this as a separate video from the rest, from part A. Part A is more to do with differentiation and the product rule. So in part B, it says use the equation in part A, which was basically this we formed after we found, basically we had to differentiate this equation. Let's just quickly recap. You had to find where the gradient of this curve was equal to 15. So we had to take this and differentiate it, find the gradient function equated to 15, and we ended up with this equation, okay, which is simplified as follows. So basically, they're telling us that the solution to this equation is between 1.7 and 1.8, and we have to show by calculation that it is between those values. All right, so we could use any form of this equation from here to there to there, any form of this equation, all right, for us to prove it. Okay, basically what we have to do is we have to make the equation equated to 0 and call it f of x, and then substitute the values of 1.7 and 1.8 into it, and then show that there's a change in sign. So I could use the equation in this form once I've differentiated it, in this form, in that form, or even in the final form that they gave us. So that's exactly what I'm going to do. I'm going to use it in this final form here. So I know that if I rearrange this to make it say equals 0, I'll have x minus the square root of 75 times e to the power of negative 0.2x over 15 plus x. One of the reasons why it's good to use it in this form now is because we already were given this form, so we know that this is definitely a correct form to use. So I'm going to rename this as f of x. I'll say let f of x equal this whole thing, so x minus the square root of 75 times e to the power of negative 0.2x over 15 plus x. Okay, so now what I can do is I'm going to substitute in here the 1.7 and see what I get. So I have 1.7 minus the square root of 75 times e to the power of negative 0.2 times 1.7 over 15 plus 1.7. I'm going to see what I get. All right, and I'll do the same thing for 1.8. I'll put 1.8 in this equation. I'll get 1.8 minus the square root of 75 times e to the power of minus 0.2 times 1.8, okay, over 15 plus 1.8. And then I'll see what I get. Hopefully there'll be different signs, which shows that there is a root between them, which I'll explain in a minute how we can deduce that. Okay, so let's just do the calculation first. So we're going to do 1.7 minus the square root of 775 times e to the power of negative 0.2 brackets 1.7 all over 15 plus 1.7. Okay, so that should give us a value. Let's see what it gives us. It gives us a negative value, negative 0.0879. Negative 0.0879. I just found it to 3SF, no problem. I just have to see that there's a change in sign. So let me just now replace the 1.7s everywhere with 1.8. Messed that one up, 1 second. 1.8. And up here, 1.8. There's somewhere else at the beginning, 1.8, 1.8, 1.8, 1.8, those places. Hopefully this will be a positive value. Yes, it is. Good. That's 0.0352. 0.0352. So now what we can say is, as between x equals 1.7 and x equals 1.8, there is a change in sign of f of x, and what I've called f of x is a continuous function always best to write that as well, as it's a continuous function, therefore a root lies between x equals 1.7 and 1.8. Okay, so that statement should be written down. And how does that prove it? Well, supposing this is our x-axis. Okay, the root is where something crosses the x-axis. So this is the x-axis. Say this is 1.7 and say this is 1.8. And 1.7, when I put 1.7 inside the function, it gives us a negative value. When I put 1.8 inside the function, it gives us a positive value. So however it curves, it doesn't matter, we don't know how it curves, but however it curves, we can see that somewhere between these two values, it crosses the x-axis. So there's a root somewhere between 1.7 and 1.8. If they both have the same sign, then we couldn't be sure that they cross the x-axis. But because they have different signs, there must be a root somewhere between these two values. Okay, so that's how we can explain that, using this change of sign method. So that's part B. Okay, so that statement, you don't just leave it written like this. You must mention some sort of statement. You have to write something down about there being a change in sign between these two values of the output of f of x, and it's a continuous function, so therefore a root must lie between them. Now for part C, it says use an iterative formula based on the equation in part A, which is this equation here, to find the x coordinate of P correct to 4 significant figures. Give the result of each iteration to 6 significant figures. So what we're going to do is, I'm going to make the iterative formula, which is basically x n plus 1 to get the next value of x. We're going to take the previous value of x and put it in here. So we have 75 times e to the power of negative 0.2 x to the power of n over 15 plus x to the power of n. Right, and we can start with, for example, x0, like the initial value. We can start with it being something close to the root, which it could be 1.7, it could be 1.8. Okay, I think 1.7 is slightly, in fact 1.8 is slightly closer to the root, because that's a shorter distance. Maybe it's closer to 1.8 than 1.7. I'm not sure. We can just choose. We could choose the initial value is 1.8. We can choose as 1.7. It really doesn't matter. Okay, it should take us to the root. So let's see what happens when we put 1.8. We have x1 equals the square root of, we have 75 times e to the power of negative 0.2 times 1.8 over 15 plus 1.8. Now there's a nice easy way to deal with the question from here on, and that is to use your calculator and use one of the features of your calculator, the answer feature. So what I'm going to do is, as I want to use my initial value is 1.8, I'm going to press 1.8, I'm going to press equals. So that's now my answer in the calculator. That's the answer. When I press answer in the calculator, it's now 9.9 over 5, because that's the last thing that was there after I pressed equals. So now if I set up this equation here, or set up this expression here, 75 times e to the power of negative 0.2. Now I'm going to put times answer. So right now what's going to go in here is 1.8, because that was the last answer in my calculator, divided by 15 plus, and again I'll put answer. So in this, when I press equals, it's going to give me x1. It's going to give me the value of x1. It's going to replace these two places here with 1.8, because 1.8 is what the answer is. So I press equals, and it gives me 1.764830. So they say give result of each iteration to 6 different figures. So that's going to be, that's 4, 5, 6. So 1.76483. Okay, so 1.76483. So that's x1. Now to find x2, I simply just take this value and put it back into there. Now the good thing about what I've done is, because I pressed answer, I use this answer feature. Okay, what I can do is I can just press equals, and it's going to give me x2. It's just going to put that answer back into here. So now what's going to happen is, where it says answer, this is going to replace it. Is exactly what I have to do for iteration. So when I press equals again, it should give me something which is a bit closer. So 1.7 let's see what we get. 2904. So that's 6 significant figures. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So yeah, I have to stop here. 290, 1.77, 290. Okay, and then I do the same for the third x3. I'll just press equals again. It will put this in there now. I'll get 1.77105, 1.77105, 77105. It seems like it's settled down up to the third significant figure. We want to stop at 4 significant figures, so we carry on. Press equals again. Okay, so you have 1.77147. That's x4. 1.77147. Okay, so it looks like it might be 1.771, but let's carry on and make sure. So we have the 5th iteration. We're going to press equals. Yeah, it looks like it's settling down to 1.77138. Okay, so 1.77138. It looks like it's going to be 1.771, and basically, if we keep going, we can see it's going to just, you know, settle down eventually. So yeah, it looks like it's x equals 1.771 to 4 decimal places. So there's the answer. Now, if you want to be 100% sure that this is your answer correct to 4 significant figures, what we could do is we could find the upper bound of this value, 1.771. Okay, and the upper bound of this will be 1.7715. And the lower bound of this value will be 1.7705. Okay, and if you think about it, if we have 1.7715, 05, and then 1.7715, halfway between them, of course, is 1.771, right? You can say 10. Okay, so what we can say here is basically that if the root lies somewhere between these two values, when you round it, okay, if it lies somewhere between these two values, so supposing it's somewhere over here, okay, when you round it to 4 decimal places, it's going to round to this number here. Okay, anything that's between these two, when you round it, it's going to end up there. If it's just below this, you can just below this, and just from there all the way to just below that, it will round to 1.771. So what we can do is we can take our function that we had before, and we can put inside it 1.7715, and we can put it inside it 1.7705, and we can see what we get. So if we go back to the calculator, and let's see, hopefully we've saved that what we put there before. Did we? Has it got it saved? No. We can go back to this. Okay, so I don't have it saved here, unfortunately, so we'll just put it in again. So we have 1.7715 minus the square root of, we have 75 times e to the power of negative 0.2 times 1.7715. Okay, close that bracket, over, good, 15 plus 1.7715. Now that gives us a positive value. That gives us a positive value 1.29 times 10 to the power of minus 4. So positive 1.29 times 10 to the power of negative 4. Now if I put in here 1.7705 instead, so if I go and change this for a 0.5 in this position, and also in this position, and also back here. All right, hopefully this will give us a negative value, and it does. Okay, so you have negative 1.10, negative 1.10 times 10 to the power of negative, was it also 4? Negative 3 this time. Okay, so we can see there that as there is a change in sign between x equals 1.7705 and 1.7715, therefore the root lies somewhere between them, and it will round to 1.771 for 4 significant figures. Okay, any number that lies between these two values, when you round it to 4 significant figures, it's going to become 1.771. Okay, so that's a way to further prove it. You can actually just do the iterations until things settle down. Just write down the values and then write down your, round it to 4 significant figures as they ask you to do here. Or you can prove it if you realize it's going to become this value. You can prove it by finding the upper and lower bounds of what you think is the answer, and then showing that the upper and lower bounds will give you a change in sign, which means that they will round to this value. Okay, whatever the root is, if it lies between those two, it will round to this value to 4 significant figures, which proves that this is the root to 4 significant figures. So there's different ways you could go about part C. Okay, once you've got to something that's close to the root, this is a way to completely prove it 100%, and that's the answer here for question number 6, part B. And that 6C, that concludes this question. As I said, part A of this question is saved under a different playlist apart from the playlist for the paper. So you'll find all the questions in this playlist, including 6A from this paper. Here you'll find all the questions dealing with iteration and numerical methods. I'll have a playlist here just for that. You can subscribe to my channel by clicking on this link, and the video here will show you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.